and welcome mindsetters to this session of Learn Extra Live for the Matrix. Hope you guys are ready and you're here with us. You're going to be making sure that you have notes ready and you're going to be working through the questions with us and posting on the page. But yes, I'm Ty and I've got Peter here with me who's going to be taking us to today's session. Peter, what are we looking at?
Well, we're going to be doing a lot of revision stuff. I think what we're going to be doing, though, is we're going to be focusing on types of graphs, okay? And yeah, hopefully students are going to be tuned in and really enjoy it. I'm kind of sad this is our last Thursday evening session for the year.
And it's your birthday as well?
It's my birthday as well, I kid you not. And talking about birthdays, let me tell you this, that our grade 12s, okay, were born, or most of them would have been born in about 1994, which was the year of our first democratic voting. I find that an interesting fact.
That is quite an interesting fact.
So they've always lived under the current government, which is fantastic.
And just reminds me how old I am.
Absolutely. All right. Did you vote in 1994?
I
think you were too little.
Yeah, still
that's
pretty
kind
young.
of scary. All right. Folk, we're going to be doing some graph work. I'm going to go over there. You're going to be chatting.
While I do this thing, yeah.
Yep,
all right.
thanks.
So while Peter makes his way over there, mindsetters, make sure you get on the page. Let us know what you guys think. If you're lost in, if you need help, post. I cannot stress this enough. And by the way, we are so close to our 21,000 mark. I am literally biting my fingertips because we're so close. Just tell your friends to tell their friends to make sure that they get on the page, because don't forget, Matrix, there will also be exam school for you guys, so make sure you tune in and check our events page, because our events page will have all of the dates and schedules for all the revision dates. So make sure you just use it, because it's just going to be helpful for you guys. But on that note, this is where I hand over to Mr. Peter. Peter, take it away.
Right, guys, and remember our revision sessions are actually made up of some pre-recorded sessions, and they're normally followed by a live session, okay? So what can happen is while you're doing your revision, you can watch those sessions during the day, write down any questions you may have, and then when we give you the live show, you can actually write in and say, hey, you know what, I didn't understand this, or I didn't understand that, please help me.
Exactly.
Remember, these revision sessions are entirely for you folk, okay? It's for you to learn. So you ask the questions and we'll try and answer them. Okay, my first question behind me, let's have a look at it. This is adapted from our September 2012 paper, or the Eastern Cape September 2012. Right, let's have a look at it. Seaview has fixed costs of 375 Rand every month. Her other expenses are for the material she uses to make her jewelry and beaded traditional clothing. 1 month, she decided to keep a record in table form of all her expenses and sale of jewelry to see how her business was doing. Okay. So here's Seaview, she's got a little business going, and she draws up a table and says, right, I have so many expenses, and I've got so much income coming in, and she writes all this down, and she comes up with a table. And the table says this, the number of items that she sold, okay, here's the number of items she sold, all over there. The expenses she is incurred, right? So in other words, how much does it cost her to make all those items? And finally, the income, and that's something we always love to know about. How much money am I getting in by selling certain amount of items? Now, using the data from the table, draw a line graph showing Seaview's expenses and a graph showing her income on the same set of axes. Plot your graphs below. Okay, guys, now, I've got an empty set of axes somewhere here, I think. Where is it? Here's my set of axes, okay? And what I'm going to do is this. In this particular set of axes, we are not given any figures at all, right? So we've got to put those figures on my table. So what I'm going to say is this. We know that running across at the bottom, I have the number of items. Now, how many items do I go up to? I go up to a total of 200 items. So somehow I've got to fit in 200 items along the way here. So how many lines do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 items. Okay. if I make each little block, all right, 10, I should be able to fit them in. So I'm going to say each block is 10. So I've got, and I'm not going to write it all down, 10, 20, 30, 40, 50 over here. Okay, let's just go up so we can see what we're doing. 50 over here, 10, 20, 30, 40, 50, 60, 70, 80, 90. Here we've got 100, okay? 110, 20, 30, 40, 150 over here, 60, 70, 80, 90, and 200 on this line. So 150 there, 100 over there, and 50 over on that line. Okay, now the next thing. Here is my expenses and income. And I need to know how much does each line represent. In order to do that, let's find the highest amount of money I've got to put in. The highest amount of money I've got to record, rather, is 3,000 Rand. Now, how many little lines do I have here? I've got, if we're starting at this point over here, right? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 odd little lines. Now I'm going to say, what is 3,000 divided by 20? And I'm getting an answer of 150. You know what? I'm going to make it more or less, I'm going to go about 200 Rand a line. So I'm going to say, right, 2, 4, 6, starting here, 2, 4, 6, 8, there, my pen, let's try that again, 2, 4, 6, 8, over here, I've got 1,000 Rand, 2, 4, 6, 8, over here, I've got 2,000 Rand, 2, 4, 6, 8, over that line there, I've got 3,000 Rand. All right, now let's plot our expenses first, shall we? We're saying if we sell no items, my expenses are going to be 375 Rand. Why? Well, if we read the question, it said right there that she has expenses. In fact, it's on the previous page. But it said before she's even made anything, there's an expense of 375 Rand. And that expense could be because she's renting a table at a flea market or doing something that's costing her some money. So before she's even made a bead, she has an expense of 375 Rand. So we need to put that in. Okay, now folks, behind me it's quite difficult to be accurate. I'm going to try my best, but understand that when you've got a graph paper in front of you, you can be a lot more accurate. Okay, so 375 Rand. So we know 375 Rand is roundabout at that point over there. Okay, we told then as well that if you notice the difference, we're going up 50 Rand, aren't we? The difference here is 50 Rand, 50 Rand, 50 Rand, 50 Rand. Because there's an increase, a constant increase, I know I'm going to get a straight line. So what I'm going to do is I'm just going to measure 2 or 3 of them. I'm going to say when 30 items are sold, my expenses are around about 525 Rand. So 30 expenses, 525, 2, 4, 6, 525 is round about over there. I'm jumping right to the end and saying, when I've got 200 items, my expense is 1,375 Rand, which is 375 is round about that point. Now, I'm going to try and draw a straight line. Here we go. So I'm going to start at this point, and I'm drawing a straight line all the way to that point over there. Okay? That shows all my expenses. Now what I'm going to do, I'm going to try and draw a line showing all my income. If I sell no items, folk, I'm getting no money coming in. I think that stands to reason, okay? You're not selling anything, you're not going to make money. So I know I'm starting at my 0 point. You can see that every 10 items, it's going up 150 Rand. So I know I've got a constant line again. So I'm going to find somewhere in the middle and a point right at the end and try and join those points. So let's have a look at that. I know if I've got 40 items, I'm going to bring in 600 Rand. 40 items on over here, 600 Rand, 246 over there. Okay? And finally, 200 items brings me in 3,000 Rand. That point over there. Now, let's try and draw a nice straight line again. From 0 all the way through to 3,000 Rand. Sure. Do you notice my graphs are straight lines? Why are they straight lines? Because there's a constant or an equal expense for every single item. My income is also a straight line. Why? Because I'm selling every item for the same price. And so my income is constant, my expense is constant. Remembering, though, that my expense is not starting at 0, it's starting at 375 because there was some expense before I even made one of those items. All right, let's have a look at my next question. My next question says the following. Using your graphs, work out how much Seaview must sell to break even. Let's go back to this graph. What do I mean by a break-even point? Folk, a break-even point is that point when my income and my expenditure is exactly the same. Guys, examiners love this question for matric, eh? They really do. If you go back and you look at all your past papers, you will see invariably there's this whole thing of break-even. Where's the break-even point? What is the break-even point? How do we get the break-even point? Okay, so my break-even point is when my expense and my income is exactly the same. Where are they going to be the same? They're going to be the same at that point over there. Right. Now, where is that point? Well, if we look here, it's round about so many items sold. How many have we sold? 10, 20, 30, 35 items round about. Okay, now I want to stop and I'm going to interrupt myself, and this is important what I'm going to tell you. Let's say I don't know how to draw the graph. Let's say my graph is a total mess. Okay, I look at the graph and it's like, what happened here? Okay. So let me do one for you. Let me just pretend our graphs look like this. So I'm going to use pink, but it's wrong, okay? So let's pretend my graph, one graph looks like this, and my other graph looks like that. And the question is, where's the break-even point? Guys, they say use your graph. Now, my graph's totally wrong. But if I know that's my break-even point, and I say, right, I've got to sell 50, 60, 70, 80 items to break even, I'm going to get full marks for that question, even though my graph is totally wrong. Because my answer, if it's based on the graph, my marker has to say, hey, this guy's graph is totally wrong, but based on the graph, he's answered the question correctly. Okay? So even if you're not sure what you're doing, folk, still answer the questions. Okay, now, my next question. Calculate how much profit Seaview made this month if she sold 200 items. Okay, so we are going to try and work it out, right? So how much profit has she made if she sold 200 items? Let's go back to 200 items. 200 items, she's brought in 3,000 Rand. Her expenses, though, were 1,375 Rand. So what is her profit? Out comes my calculator, and I'm going to say, right, 3,000 Rand is what I'm bringing in, but I had expenses, and they were, let's just double check, 1,375 Rand. My total income is going to be 1,625 Rand. 1,625 Rand. Are we okay on that? Right? So did you see how we calculated profit? Because profit is my income minus my expense. If I'm making some income, I can't say, hey, this is all my wonderful profit. It's not, because I still got to pay off my expenses. All right. I think we're going to take an ad break.
Yes, we
Are we?
should.
All right.
All right, so mindsetters, keep on talking to us on the page. I'm loving what you guys are sending in. Keep on posting, and mindsetters don't disappear. We'll see you after this break. And welcome back, Mindsetters. Hope you had a nice little break. You didn't disappear or wander too far from your TV. You're back with us and you're paying attention. You got your pens, pads out, and you're going to make some notes. Don't forget you have to have your 3 Ps. Also, don't forget your phone because you need to make sure that you're talking to us while you're making notes. It's so important because we're trying to help you guys for your exams. But on that note, I'm talking about helping out. Tazana actually wanted to ask a question. If they ask for the break-even point, must we give the coordinates? If no, how do we know when to give the coordinates?
All right, great question, folk. So if they want to know the break-even point, so for example, in this question, here's my break-even point over here. Oops, let's just get a pen for that. Okay, so here's my break-even point here. Now, they will say one of two things, or ask one of two things. They could easily ask, how many items need to be sold to break even? Well, in this case, we said it was around about 35 items. They could also ask the question, how much money is at the break-even point? Okay? Well, then we're going to read it off, this value. Very seldom do they ask for the coordinates. Read the question carefully, but that was a great question. Okay? So they will say either, how many do we need to make, or what's the value of that break-even point? It's all in the question. Okay, shall we move on? Let's go on. Our next question then today is this. JMO, a grade 9 learner, conducted a survey to give to the tuck shop at the school as an indication of the favorite chocolates they have to stock. He conducted the survey in his class. Right. Below is a bar graph to show JMO's findings. So JMO says, hey, listen, I'm going to help out the tuck shop. I don't know if these guys are selling the right chocolates, okay? Do we like them? Don't we like them? I'm going to help them out and give them some guidance. So he goes off to some classmates and says, right, you tell me, how many of you like crunchies? And guys, put up their hands. How many put up their hands? 6 put up their hands for crunchies. Can you see that? Okay. How many like bar ones? 10 of them like bar ones. How many like new looks? 8 of them like new looks. How many like lunch bars? 14. How many liked inside stories? Oh, shame, only 2. That's terrible, because I love inside stories. I think they're absolutely fantastic. When you take it and you break, and that chocolate just melts in your mouth. It's wonderful stuff. Okay, so there is my bar graphs. Now, here's my first question. How many learners did JMO interview? Ooh, how are we going to work that out, guys? Well, it's quite simple, eh? We're going to presume that everybody did have a favorite chocolate. Now, here he goes, and he's got 6 guys over there. Let's use a different color for that one, shall we? Let's try white. Will white come out clearer? Yeah, it does. So 6 like crunchies. We said 10 like bar ones, 8 like new looks, and 14 like lunch bars, and sadly only 2 liked inside stories. How much is that in total? Well, let's take out our calculator. We've got 6 guys there plus 10 guys over there plus 8 chaps like new looks plus 14 students like lunch bars, and finally there were only 2 liked inside story, so we've got a total of 40 students. So how many students did he interview? He interviewed 40 of those students. Oh, and you know what? I know this doesn't have it here, but I can just see so many probability questions coming out of this one. I really can. Like, for example, if I randomly grabbed a student, what's the probability that that student would love an inside story? Well, there would be 2 over 40. Agreed? Which would simplify to 1 over 20. How many students would like either a crunchy or a new look? Well, it's 6 plus 8, which is 14 over 40, which is going to simplify down to, what's that, 7 over 20. Okay, great probability questions here. Interesting stuff. And I know our producer just loves probability, so I had to throw that in there. Okay, now, next one. If there are 1,030 learners at JMO school, calculate what percentage of the learners he interviewed. Give your answer to 1 decimal place. Now, grade 12, I mentioned this last week. Let me say it again. If your examiner tells you, round your answer to 1 decimal place, what he's actually telling you without verbally saying it is this. You're going to get a horrible answer here, pal. It's going to be ugly. It's going to be comma, something, 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 something. So round it. So I know when I calculate this, I'm expecting a horrible answer. Okay, so let's do that. So how many students did he interview? He interviewed only 40 little students. How many in the school? 1,030. We want to convert that to a percentage. So I'm going to say, right, out comes my calculator, and we're going to go. Fraction button, we've got 40 students over 1,030, multiplying it now by 100, and we get an answer of, and remember we said, and there it is on your screen, okay, we said it was going to be a horrible answer. Look at this thing. 3,88349, but that's okay, don't panic. We knew it was going to be like that. So what is my answer? It's going to be 3,9. So my final answer here is going to be 3,9%. Sure. That's not a lot of the population of the school that's been asked, is it? Let's look at our next question. Do you think this information is representative of the learners at JMO School? Give a reason for your answer. Well, I don't think so, because he's only asked 3,9% of the school. And if you've only asked 3,9% of the school, what happened to the other 96,1% of the school? The other thing I think is this. If we read the question, it says here quite clearly that JMO asked students in his class. So he didn't ask a few students from this grade and a few students from that grade or that grade or this grade. He just asked students in his class. Do I think that's fair? I don't think so. All right? Because his class might be a group of grade 12s. And little grade 8s might like little crunchies or something. Whereas the mature grade 12s, they're saying, hey, you know what? We like good lunch bars. The little kids might say, we love crunchies because we just love it when it goes crunch, 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 crunch in our mouth. Got the idea? Okay. Now, next question. Do you think the heading of the bar graph is correct? If not, correct the heading. Let's look at the heading of it. It says, favorite chocolate in my school. Well, I don't think that's correct at all. Why? It should be in my class, because he only asked students from his class. Okay. Next one. The lady in charge of the tuck shop is not happy with JMO's findings and asks him to conduct a survey that is more widely spread. Explain what she means by more widely spread. Well, we've answered that already. Hey, he's just asked the students in his class and not in the whole school. Next question. To keep the favorite chocolates of the learners in stock, she would like to see 40% of the school's learners interviewed. How many learners must JMO interview? So we want to find out what is 40% of the school. So let's have a look at it. How many? We want 40% of learners in the school. How many learners do we have in the school? We've got, where does it say here? It said here somewhere, 1,030 learners. So times 1,030 learners. And again, folk, our calculator is going to do that for us. So we're going to say, fraction button, 40 over 100. And we're going to multiply that by 1,030. And we get a final answer of 412. So what the tuck shop lady is saying is this: don't just ask 40 students, pal. I want you to ask 412 students. Because if you ask 412 students, that covers 40% of the school. Then I will have a better idea of what chocolate is the favorite. Okay, now let's go through this next question. This question's a lovely question, hey? The following graph shows the percentage change in the price of a crunchy bar from 2007 all the way through to 2018. and 11. Now, folk, there are a few things I've got to bring to your attention here. It's showing the percentage change. Okay, so let's have a look at that. So in 2007, crunchies changed by 2.9%. In 2008, they changed by 2.5%. 2009, the price went up by 5.7, 7.8, 12.8%. Now, here's an interesting question. And I actually think it's a horrible question because it would have confused a lot of students. Let's have a look at it. In which year did the price of the Crunchy bar decrease? Explain how it's illustrated on the graph. Okay. Now, folk, I know what a lot of people are going to say. A lot of people are going to say, that Crunchy decreased in price in 2008. How do we know that? Because my line is going down. Well, actually, no. Get that out of your mind instantly. The price of the Crunchy still went up, but it didn't go up as much as it did in previous years. So if you look here, in 2007 it went up by 2.9%. In 2008 it still went up, but not as much. It went up by 2.5%. Guys, this is a horrible question, because it's implying that somewhere along there my price of my Crunchy's gone down. It never went down. It still went up, but it didn't quite go up as the other years. Look here. This one went up 2.09, 5.7%, 7.8%, 12.8%. This year it went up, but only 2.5. And when I've joined these dots, it looks like this line is going down. And because it's going down, so many people are going to say, check, the price of the Crunchy, it went down. It did not go down. It just didn't increase as much as it should have. So how would the graph look if the price had gone down? Well, what we would have then done is we would have had a graph. I'm going to go right to the bottom here and try and get a blank area for me. This is my 0%. Here is 1%, 2%, let's say 3%, okay? Over here, -1, and over here, -2. If I gave you a graph like this, and I said we've gone up 2%, gone up 3%, then over here, now we over here, now let's go down here, right? The bar chocolate has increased by 2%. At this point, it's increased by 3%. At this point, it's still increased, but by not as much. It's increased by 1%. At this point, it's increased by 2%. Over here, what's it increased by? It's increased by -1%. In other words, now, at negative, the value of the chocolate has now gone down. Do you understand that? Now, a question very similar to this came up in the 2008 paper, and I think around about 2010, 2011. Can't quite remember. Very similar question. Okay, guys, this is not a negative increase. It's still an increase, but the increase isn't as much. The negative increase comes when we've got a negative number on my scale, when it's below 0, like 0.1. Okay, let's have a look at my next question. Now I've got to go all the way up again.
I'm just going to jump in there real quickly. I think we should take a quick ad break.
Are we going to do? Let's do that then.
All right, so mindsetters, don't disappear. Stick around. Make sure you get on the page. Keep chatting to me. Keep sending in your questions if you're lost anywhere, if you need help. Post them. But for now, we'll see you after this break. And welcome back, Mindsetters. Hope you had a nice little break. You went and did whatever you had to do. If you had to go to the kitchen and you had to go cut up some veggies, whatever you had to do, make sure you're back, you're ready, you have your pens, pads, and your phone so you can make sure that you're making notes while you're sending in your questions. It's so important. It's so easy. Don't forget, you can also email us at our help desk. So Mindsetters, just use that stuff. It's for you guys. But anyway, we have a session to do so, Mr. Peter. Take it away.
Right, folk. Earlier on in the session, we mentioned something about probability, and suddenly the page became very full with people saying, please do some more probability things. So let's have a look at this question I got behind me. What I'm looking behind me is a contingency table. So what does that all mean? Well, let's have a look at this. So Miss Betty only invited children aged 2 to 5 years old. Study the following contingency table and answer the questions that follow. Now, guys, I know this part of it doesn't kind of make sense because, and the reason for that is this is taken out of a middle of a whole question. So there was a huge question, and suddenly in the middle of the question, there was this little probability and contingency table. So we're not going to do all the bit before that. So that's why it kind of feels a bit weird that suddenly we're saying, who on earth is Miss Betty and all the way? Don't worry about it. Okay, study the following contingency table and answer the questions that follow. So here we go. Right, so we've got age of boys and girls invited to a party. So here, in this column over here, we've got 2-year-old kids. In this column over here, we've got 3-year-old kids, 4-year-old kids, and 5-year-old kids. Please understand that the table consists of both columns as well as different rows. Got that? So if I look at my columns are telling me the ages of my different students. The rows, on the other hand, are telling me whether we're dealing with boys or whether we're dealing with girls. Right, so what I want to point out is this figure over here, number 45, because every single row, this 5, this 3, the blank, has to add up to whatever is in there. All my rows have to add up and all my columns have to add up. And if I've done everything correctly, my final figure is going to have to be 45. So let's try and answer this. Now, folks, to answer this kind of question, what we've got to do is we've got to look at our table and we've got to try and find out if there are 3 things in my column. I've got to try and find a column where I've got 2 items and only 1 missing. Because if I've got 2 bits of information, it's easy to find the 3rd one. And if I look at all my different columns, if I go across on the rows, I've got 1, 2, 3, 4, 5 bits of information. To do a row, I've got to know 4 bits of that information to answer one of the 5th bit. Okay, so when I start off, this is straightforward. Look what I'm going to do. I've got boys, I've got girls, I've got total. If I look here at 2-year-old, 5 plus what gives me 9? Well, that's easy, hey? 5 plus 4 is going to give me 9. Now it's exciting, because now if I go across on my row, I've got 4 plus 8, which is going to give me 12, plus 5, which is going to give me 17, plus 6 is going to give me 23. Now that's exciting. Because I have 23 here, I know this figure over here is going to be something plus 23 gives me 45. And I know it's 22. So 22 plus 23 gives me 45. Is there anything else I can find? Let's look at my 3-year-olds. 3 plus 8 gives me 11. Okay, anything else I can find? Yep, I can. What plus 6 gives me 14? 8 plus 6 gives me 14. Now let's look at our boys. We want to say 5 plus 3 plus 8 plus what gives me 22. So let's have a look at it. Okay, so we know 5 and 3 is 8. 8 and 8 is 16. If I add another 6, I'm going to get 22. Now what's 6 and 5? 6 and 5 is 11. Right, I think I've filled in everything. Let's double check all our rows and all our columns and see if they all add up. I'm going to start with the actual columns. So 5 and 4 is 9, 3 and 8 is 11, 6 and 5 is 11, 8 and 6 is 14, 22 and 23 is indeed 45. Let's go along our rows. 5 and 3 is 8, 8 and 6 is 14, 14 and 8 is indeed 22. 4 and 8 is 12, 12 and 5 is 17, 17 and 6, 23. 9 and 11 is 20, plus 11 is 31, plus 14 is going to give me 45. Guys, everything works. My rows all have added up. My columns, they too have all added up. So my contingency table is working out. Done 4.3.1. Let's look at the next one. Use the completed contingency table to calculate the average age of the children who were invited. Oh, now, I know what so many people are going to do. So many people are going to say, this is so easy. What we're going to do is we got 2-year-olds, 3-year-olds, 4-year-olds, and 5-year-olds. So we're just going to say 2 plus 3 plus 4 plus 5, and we're going to divide it by 4. And that's going to give the average age of the children that are at my party. Well, that's not true. And I'll tell you why. Because if you look, I've got 9 2-year-olds. I've got 11 3-year-olds. I've got 11 4-year-olds. I've got 14 5-year-olds. So because those numbers are not constant, I can't just say 2 plus 3 plus 4 plus 5 and find the average. In fact, guys, this is a phenomenal paper 2 question. Okay, fantastic question. Gives me an idea for setting a paper for my grade 12s next year. Now, let's have a look at it. So I know I've got 9 kids who are 2 years old. I've got 11 kids who are 3 years old. I've got another 11 who are 4 years old. And finally, I've got, oops, I went a bit too high there, 14 who are 5 years old. So what I'm now going to do is say, well, now let's find the total age of all the kids in the party. So we're going to say 9 times 2 gives me 18. Right. 11 times 3 is going to give me 33. 11 times 4 is going to give me 44. 14 times 5 is going to give me 70. Cool. Now, let's add it all up. So we're now going to say, right, I've got 18 plus 33 plus 44 plus 70. And my total age is 165. So were I to add up all their ages, I've got a total of 165 years. Please understand, a 2-year-old, 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 3-year-old, 4-year-old, 5-year-old, 5-year-old, 4-year-old, 3-year-old, 2-year-old, okay? We've added up all the ages, and we've got 165 years. Now, how many kids were at the party? Do you remember from our contingency table? Here it is right over here, 45. So I'm going to say 165 years, divide that by 45. So let's take out our calculator, 165, divide that by 45, and I'm going to land up with a weird answer of 3,66. I'm going to say 3,67. So the average age is 3,67 years old. Okay. And this question didn't say how many decimal places we've got around to, but, and if it doesn't do that, I turn to the front of my exam cover, and it would probably say, where necessary, and unless otherwise stated, round to 2 decimal places. And that's exactly what we've done here. Let's look at our next question. Our next question, here it is. Use your completed contingency table to answer the following questions. Calculate the probability that a girl aged 5 years will be invited to the party. Okay, so we know out of all the kids that are at the party, there are 45 of them. So we've got 45 in total, and how many girls aged 5 do we have? We've got 6 of them. So we got 6 over 45. Can I simplify that? How do I know if I can simplify that? Guys, I'm going to go to my calculator, and it's going to do it for me. And I'm going to say, right, I've got 6 over 45 equals, and the calculator simplifies it for me and says, oi, simplify that, please, and make it 2 over 15. Right, next question. Calculate the probability that a boy will be invited to the party. How many students are there? Or how many kids at the party? 45. How many of them are boys? Here it is here. 22. So I know there are 22 out of 45. Can I simplify that? How are we going to do it? Yes, correct, with that calculator. So out comes my calculator, and we're going to say, right, I've got fraction button, 22 over 45, and I get an answer of 22 over 45. What's that mean? It means, folks, I can't simplify it. Okay? If the calculator can't do it, I can't do it, you can't do it. Calculator's right. 22 over 45 is my final answer. There it is there. Now, final question then is this. Calculate the probability that a boy or a girl of 2 years will be invited to the party. So we've got 45 students in total. We want to know how many 2-year-olds are there. How many in total? There are 9 boys and girls aged 2. So it's 9. Can I simplify that again? Guys, you know the drill. It's going to be 9 over 45. And my answer, 1 over 5. So this can indeed simplify. And it's going to be 1 over 5. Which is fantastic. I'm glad we did this bit of probability, and I know it's our last show, but you know what? Probability comes up, and a lot of students battle to understand this concept. So thanks to all of you who said, please give us a question probability. That's what we've done, and we hope you've helped us. We hope we have helped you. Okay, you've helped me as well by giving us the question. All right. I think we've got one more session after this break.
I
Over
think so
to you,
too.
Ty.
So mindsetters, I'm just saying, make sure you jam our page with the questions that you really need answers desperately for. So make sure that you keep on posting, keep talking to us, keep letting us know what you guys are thinking. But for now, we're going to see you after this break. And welcome back, mindsetters. Just want to say thank you so much for joining us for today's session. So make sure you keep on chatting to us for the rest of the session and talk to us. Let us know what you guys are thinking. If you're lost anywhere, if you need help, post it on the page. But for now, we have a session to continue. So, Mr. Peter, take it away.
Right, and sadly, folks, this is our last session for a Thursday night, and we don't have very much time. In fact, we've got just under 10 minutes, which is so sad. So I thought I'd end off with looking at a question to do with shape and measurement. All right, let's read this. The dimensions of the crunchy bar are illustrated in the diagram below. Please note, the diagram is not drawn to scale. Now, calculate the volume of the crunchy bar. Give your answer in centimeters cubed. Use the formula volume equals length times breadth times height. All right, here is an important thing for you to remember. Before I tackle any question to do with area, to do with volume, to do with perimeter, folk, make sure, mark circa. What's that in Zulu?
I have no clue.
No clue. Okay. Make sure that all your units are exactly the same. Look at this diagram here behind me. Can you notice something here? So I have right over here 1,5 centimeters. I have 2,5 centimeters. Then I have 128 millimeters. Guys, that's not good. I cannot, I may not, I shall not, it's like commandment number 11, okay, ever work with perimeter, area, or volume if my units are not the same. So, let's change this straight away. How many millimeters in a centimeter? There are 10. So 128 millimeters is going to give me 12,8 centimeters. So I've got 12,8 centimeters. Now that I know that, I can now calculate my volume. And let's have a look. It's right there on the screen. It gives it to us, eh? It says volume equals length. What's my length? Well, I know what it is now. It's 12,8 centimeters multiplied by my breadth. What's my breadth? 2,5 centimeters. And what is my height? My height's 1,5 centimeters. Now, all we've got to do is punch that into our calculator, and we're going to get that answer. So out comes our calculator. I'm going to shift it over here because it's in the way, and I'm going to say, right, 12.8 multiplied by 2.5 multiplied by 1.5, and I get a final answer of 48. Okay, now 48 what, people? We're dealing in centimeters. Let's clear that up first. Okay, so we're dealing in centimeters, so it's 48 centimeters. But because it's volume, it's going to be centimeters cubed. In fact, if you look at the question, it says give your answer in centimeters cubed. That was a bit of a giveaway, wasn't it? Okay, this examiner, he was on your side when he set this paper. Right. I think if I set a paper, I wouldn't tell you, hey, remember, units and cubed. You should know volume is always units cubed. Area is always units squared. Perimeter is just the units. Got that? Let's go on to our next question. Our next question is quite a nice one because it's to do with area. And it says the crunchy bar needs to be covered with chocolate. Calculate the surface area of the crunchy bar in centimeters squared. First thing I'm going to do is get rid of that and write 12,8 centimeters. Okay. Now, how are we calculating the surface area? So, with the surface area, we're saying how much chocolate do I put on top of the crunchy? How much chocolate do I put at the bottom of the crunchy? How much chocolate on the sides and the front and the back? So to do that, we've got to calculate all those areas. The top, the bottom, the sides, the back, the front. And you know what the nice thing is about the shape? They're all rectangles, so it's straightforward. Let's have a look. If I look at the front, okay, what am I seeing? I'm seeing this shape over here, a rectangle. And we know the area of a rectangle is length times breadth. So I'm going to say, right, my surface area is the front of that crunchy, which is how long? We've got it up here, 12,8 centimeters, multiplied by a height of 1,5 centimeters. I'm now going to say times 2. Why times 2, folk? Because I've got the front as well as the back. So it's got to be times 2. But then, so I've taken care of this side over here in the back. Plus, I've got to find the sides. What's the area of the sides? Again, folk, it's in the shape of a rectangle, hey? So it's length times breadth. So I've got 2,5 centimeters multiplied by the height of 1,5 centimeters, and again times 2. Why times 2? Because there's this side and there's that side. Got it? Shall I show you again? There's this side and there's that side. Right. What else has got to be done? All that's got to be done is the top now and the bottom. So I'm going to say plus, well, I'm running out of room, so I'm just going to do it down here. Plus the top, 12,8 centimeters times 2,5 centimeters. And again, folk, times 2. Why times 2? Because it's the top as well as the bottom. Okay, so now we're going to go down and we're going to say, right, now let's just calculate all that. And what I'm going to do is I'm going to calculate the little bits at a time. I'm not going to do the whole thing in one shot. I'm just going to calculate the first bit, get the answer, next bit, get the answer, and then I'm going to add, just in case I make a mistake with my calculator, because that's quite a lot of stuff to type in. And if I mess up, oh my giddy aunt, what a mess that'll be. So out comes my calculator, and again, I'm going to shift it this way now, and I'm going to say, right, I've got 12.8 multiplied by 1.5 multiplied by 2 equals, and my answer is 38,4. So I've got, I'm going to use a different color, 38,4 what? 38,4 centimeters squared. That's that taken care of. Plus Let's do the next bit. Out comes my calculator, and this time I'm going to shift it to this side of the screen. Okay. I've always got visions of our producer trying to find this thing on the screen. Okay. So here we go. 2.5 multiplied by 1.5 multiplied by 2 equals, and I land up with 7,5. So I've now got plus 7,5 centimeters squared. That's that part gone. Let's look at the final part. So my final part comes up, and again the calculator's in the way, so we're moving it again. Sorry about that. So we've got 12.8 plus 7 sorry, let's try that again. Delete, times 2.5 times 2 equals, and I get 64 centimeters squared. Okay, how are we going to find the final answer? Straightforward, folk. We're just going to add them up and get that answer, and I don't even have time to do that. Guys, it's been great with you this year. Ty, over to you.
Yes, Mindsetters, I just want to say thank you so much to all of you Mindsetters who've been joining us on the page, been talking to us, making the show what it is. It's so important, and thank you so much for you guys joining us. And Mindsetters, I just want to say, keep dreaming big, keep chasing your dreams, and make sure you study, study, study. And don't forget Matrix, you have exam school. Do not forget that. Check out the events page. No FOMO. Remember that. No fear of missing out. So make sure you get on the page. But for me, this is where I say cheers and see you next time.